Hello, welcome to Space Alive. I think we were frozen on 4 minutes 16 for a long time, so we weren't sure if we were actually going to end up going live on time. But welcome to Space Alive. Welcome to the Space Roundup. This is where we bring you the latest and greatest of space news. Hi, Nick and Terry. How are you guys doing?
Good. We had a really cool launch hold there. I liked it. 4 minutes 16. Happens to the best. Cool. Are we ready to roll?
Yeah, I think we're ready to rumble tonight. Thank you for joining us on YouTube and or Facebook. We're ready to bring you another great roundup. I hope you guys enjoy it.
Let's light this candle, as Alan Shepard once said. So welcome again. Hi from me in windy, cold and snowy Wiltshire in the UK, and over to Terry in Northern Ireland.
Yeah, windy and cold here, just a light dusting of snow.
It's nothing that would stop Roscosmos from launching, let's put it that way. Yeah. So it's been a busy day. It's been a busy few weeks, actually, but what an amazing day today. If any of you were around this afternoon, you'll have seen the incredible news that the United Arab Emirates, UAE, their first mission to Mars basically got there after, a year nearly, or just under a year of traveling from Earth to Mars at their first attempt. And that's the really cool thing about this. They got there at their first go, much like the Indian Space Agency. And both of these agencies, when they were initially proposing to go to Mars as kind of their first major interplanetary jaunt, as it were, there was a lot of mirth and laughter and people saying they'll never do it. Well, they both did it, and they both did it on incredibly low budgets, particularly the Indian mission, which cost less than a Premiership football player, if any of you know the UK's Premiership football. Now, the thing is with Mars, there's been some great books written on Mars all throughout the years. I know one of our listeners is a guy called Nicholas Booth, who's a top bloke, formerly with various newspapers and editor at Astronomy Now magazine. He's written one of the best books on this subject recently with Elizabeth Fowle, so heartily recommend that. But if you think about it, it's only just over 100 years since the likes of Percival Lowell, etc., were adamantly believing that there was life on Mars. The whole thing with the canals, some of the books published in the early parts of the 1900s saying that, potentially there was life on Mars. So it's always held this fascination with humanity as the next thing that we've got to do after the moon, as it were. And it's really hard. I mean, let's not beat about the bush here. The European Space Agency, in decades of trying, have never managed to get anything successfully on the surface. They've got some phenomenal orbiters. They've got the Mars Express orbiter. They've got there's a freeze apparently. I'm hearing that there's a freeze on their side. Shall I continue? I've got a message from my producer in the earpiece here that there's a freeze. Let's see if we got a hold. Oh, continue. Cool. Right. So the Russians, European Space Agency, never managed to get anything successfully on the surface. They've been trying for a long time. They've got fantastic orbiters, Mars Express being one of them. It's been doing great science for quite some time now. The Trace Gas Orbiter got there quite recently. But you have to look at the associated missions, the lander missions with those. So Mars Express carried the Beagle 2 probe, which was the UK's first attempt at putting on the surface. And it's probably the most successful attempt that the Europeans have ever made, because it managed to get through what's called EDL, entry, descent and landing, got to the surface. Everybody believed it had smashed and crashed. It hadn't. It actually got down to the surface quite safely, quite successfully. It looked like it unfurled most of its solar panels, but sadly it wasn't able to unfurl all of them and then basically release its transmitter to enable it to transmit to orbit. So bit of a shame there. Only in the last few years we've had the disaster of the Schiaparelli mission, European Space Agency's Pathfinder, before the ExoMars mission, which was supposed to be arriving there at this time. I'll talk about that a bit more in a minute. Schiaparelli was kind of Pathfinder lander for what they were attempting with the ExoMars mission, obviously a lot smaller. That didn't work, had issues with retro, dumped a ton of hydrazine all over the Martian surface, so not ideally something you want. The Russians, I mean, they're not much more successful. The Russians, in terms of launchers, everything that's touched the Russian launchers failed from the surface point of view. But the Russians, they had the first semi-successful landing on Mars, which most people, when you say, what was the first thing to land on Mars successfully? Well, First thing to land on Mars successfully was a Russian spacecraft called Mars 3 back in the early 1970s, before the Vikings, but it was only able to transmit for a few seconds from the surface. So there's some wonderful images of these kind of almost like data bit lines along the bottom, where it got a few lines into its transmission and then kind of failed. The first major success, obviously, 1976 with the Vikings, Viking 1, Viking 2, which were on the surface for a number of years, didn't have rovers associated with them, touched down using rockets, huge, great big things. Fantastic science coming out of those. Loads of controversy still to this day over the labeled release experiments that they were conducting on those missions, trying to detect life. It's still a hot topic to this day. Obviously, that's why lots of interest now in Mars again. There was a big hiatus after the Vikings from 1976 through to the late 90s, and then NASA went back with the Sojourner, tiny little rover about the size of a remote controlled car, which did a fantastic job, almost broke the internet at the time. Then we had Spirit and Opportunity using their airbag bounce descent mechanism, which was really risky, but Steve Squires and the whole team behind that, phenomenal job. Still going now to this day, fantastic science. One of the rovers in particular, still delivering fantastic science to this day. And then in 2012 we had Curiosity, which was the first time they tried the crazy sky crane. And that Adam Stelter and his team, there's lots of people involved in that, but he's kind of the most public face behind the sky crane. Basically is the same approach that's going to be used for the Perseverance rover landing, which is happening in just over a week from now, on the 18th of February. And that's basically, they realized with rover almost the size of a small SUV, they weren't going to be dumping it onto the surface with airbags. Wasn't going to work. So essentially what they did was they built this kind of multifaceted system where during the entry phase, it will slow down due to the Martian atmosphere. It will then deploy a huge hypersonic parachute, basically designed to decelerate it further, gets it down to a certain velocity. Then they'll drop that off, cut that off, and go to rockets. Rockets will then descend to a few hundred feet above the surface. Then they will start to deploy the sky crane, which is essentially a way of lowering the rover onto the surface using wires. Once it touches the surface, they then cut the wires. The landing descent vehicle flies away, explodes somewhere in the distance, and you've got a rover on the surface. So it's hard. Let's put it that way. I mean, everybody, when they first saw Sky Crane, thought it's completely insane. It's never going to work. It worked. Hopefully, in about a week's time, it's going to work again. With what's happened today with Al-Amal, the UAE's orbiter, is it doesn't have a landing component. It's an orbiting component. It's designed to look at the Martian weather over a number of years, look at issues of hydrogen and oxygen in the Martian atmosphere, give us a much more detailed overview of what's happening with the Martian weather. And to have so many orbiters now around Mars is incredible. I mean, the technical challenge of this, let's not, again, beat about the bush here. Launching a rocket's hard anyway, then putting it into Earth orbit, then doing a burn to set it on a trajectory for Mars, which is tens of millions of miles away, then to, at 75,000 kilometers an hour, which is how fast the UAE's probe was approaching Mars today, basically to then decelerate, slow down, get it into orbit around Mars, and then potentially, if you've got another component like Tianwen-1 tomorrow, which is hopefully going to go into orbit, that's the Chinese Space Agency's mission, which has got not only an orbiter, but a lander and a rover, and this is their first real attempt at doing anything with Mars. It's staggeringly complex. You just can't comprehend how difficult this is. So my hat just tips, if I was wearing a hat, massively to the UAE and obviously the University of Colorado and Arizona State University and University of Berkeley in the United States for incredible collaborative effort. The thing that got me most about this mission today, though, was the coverage. The press coverage was stunning. It was very, very apparent that the UAE, don't forget, parts of the United Arab Emirates area, Saudi Arabia and the kind of the Arab world within there, up until a few years ago, women weren't even allowed to drive in Saudi Arabia. So we're talking about regimes in Saudi in particular, obviously not the UAE's. It is, a different country, but you've got parts of the Middle East where, education for girls is non-existent in some respects, and this ability to drive, all sorts of silly things like that. And yet 34% of the mission team working on this were female, and they really focused on that, and it was a great thing. 80% of the science team across the UAE Space Agency are female. So it's a brilliant way, I thought, to promote both national pride. I mean, there were beaming images of the mission onto the Burj Khalifa. This is the tallest building in the world. The sense of pride from the UAE was amazing. It really was. And the fact that they focused so much on what it was doing for the economy and for STEM and for the promotion of the UAE, in terms of business growth, etc., I absolutely love this. And I just wish that other space agencies, no names mentioned, could do the same to really engage the public. I don't know, Terry, if you said you were listening to it and not really watching it, but I don't know if you've got any extra thoughts on this.
Yeah, it's remarkable in a whole lot of ways. First of all, UAE basically had no history as a spacefaring nation, and yet they came up with this in 6 years from the initial idea until actually completion. I think it was particularly to mark the 50th anniversary of the UAE, which is this February, basically. So 6 years for a mission for a country that had no background really worth talking about in space is absolutely remarkable. And of course, what it's going to do, as well as some high resolution imaging of the surface, as you were saying earlier, the most important part of the mission is to find out why the Martian atmosphere is gradually leaking away into space. We know that Mars had a much denser atmosphere in the past. It's losing it now. That's of critical importance if we ever want to think about, in the far future, trying to terraform Mars and reintroduce an atmosphere. We need to know why it's losing its atmosphere now. And that's one of the main aims of this particular mission. So it's a brilliant start to actually get it into orbit, as you were saying. And to do that within 6 years and to get it right first time is just brilliant.
Well, that's the thing. It's such a short period of time, and I work in the defence industry and big government projects, and some of those just relatively straightforward, simple software projects can take longer than that. So you can't underestimate. It's very similar, I think, to the approach taken by the Beagle team in particular, in that they had a dream, they had a goal, they didn't have a huge budget in the case of Beagle, and India obviously the same. UAE don't so much have the budgetary issues that the UK had with Beagle, but it's this rapid development time, and you only have to look at our next story, and we're going to talk about SpaceX, etc. And you look at this, what it's called agile it's an agile methodology. So it's very common now in software to kind of build, test. If it doesn't work, build again, fix. Keep going in rapid cycles. And the space sector, I think, is really now starting to wake up to this, seeing what the commercial entities have done in particular. The likes of Blue Origin, the likes of SpaceX have been doing for quite some time now, this rapid evolution, rapid development. And I think the larger space agencies in particular, you only have to look at the Artemis program and the staggering costs and the staggering overruns and the delays on that. And they've still, they've got to now redo the firing test on the RS-25 engines because the first one didn't burn for long enough. So, and the sheer length of time that it takes and the costs, therefore, associated with that. If space is going to become this change in the global economy that we all want, that we become, an off-planet capable society, as it were, generating real business in space, it'd be that, the talk about mining on the moon, and there's all sorts of like hokey plans, and some of them quite interesting plans for how we can kind of move development, as it were, the ecosystem and the infrastructure of the world off planet once we hopefully fix some of the issues we've got on the planet. And I think the approach taken by these upstarts, as it were, everyone's calling the UAE, it's like, who were they? They were doing nothing, but obviously big collaboration with some of the US universities who've got vast experience in this. But that's the way to do it. It's the way to kind of move things forward. And I think this collaborative nature, this rapid role nature, hopefully is going to become the future of space exploration as we see it. And that's what I'd love to see. I don't know if you've got any other thoughts, Terry, but that's...
No. And just, I don't know, you were going to say more yourself about the China one, Tianwen one tomorrow. Obviously, we don't know whether that's going to be successful or not, but there's a couple of interesting angles on that. It's due to land in Utopia Planitia, one of the lowest areas on Mars, and that means that it's even denser atmosphere. The Martian atmosphere is only about 1,000 as dense as the Earth's, at the surface, but the lower down you go in elevation, the denser that atmosphere gets, so you get more braking and so on, atmospheric braking. So that's going to be a critical one to watch tomorrow. They've had a very good success rate so far. They had one failure recently with something that exploded just after launch, but in terms of their missions to the moon, very, very successful so far. So I'm reasonably hopeful for their prospects tomorrow.
Yeah, I think the only issue I can see with the CNSA mission is the level of coverage. Obviously, the Chinese government and the Chinese Space Agency have been, very vocal of late with their success stories. Obviously, with the Chang'e missions to the moon, landing her over on the far side of the moon, doing fantastic work there. I don't think we're going to see something as kind of effervescent, shall we say, as we saw today with the UAE mission. I said the coverage, I've not seen anything like that since NASA coverage or SpaceX obviously do a lot of hoopla behind the coverage. It would be great to get China involved more in the global science community as well, and hopefully with the new administration in the United States, we may see some of the breakdown of the barriers. I don't know if that's going to happen, but let's all hope that it's a really successful orbital insertion for them, because they're not going to be landing for a few months yet. They're going to go into orbit, do their initial studies through orbit, and then send the lander down after they've done that, much like the Vikings initially did in the 70s. So yeah, it's going to be interesting few weeks. In a few weeks' time, hopefully, we'll have 3 successful missions.
Yeah, it's a bit like buses. 3 of them come along at once after you've waited for dear knows how long.
It really is. It really is. So we've talked about that for quite some time. We're going to move on to our next story, which is many boom, many bang. So this was SpaceX, and Terry, you've got a lot to say on this one.
Oh, well, yeah. You have to... I was going to start with Jeff Bezos, actually, and then go on to the SpaceX bang. Bezos, one of the richest men possibly in the solar... Well, definitely in the solar system, possibly in the galaxy, for all we know. He stood down as chief executive officer of Amazon, and he wants to concentrate more on space. And I suppose you could say, well, why would that be? And it could well be because Elon Musk, certainly in the popular appreciation of what's going on, is well ahead. And there's nothing like a bit of good friendly rivalry. So he's going to devote a lot more time now to his stuff. He basically wants to do more or less the same sort of thing as Jeff Bezos, doing some satellites, tourists into space, launching satellites for his own company. Unfortunately, he's going to follow in Elon Musk's footsteps and launch a constellation of communication satellites. Not quite so many, but still enough to be a bit of a problem. So anyway, he's now in competition with SpaceX and also with Dynetics, and the main thing that I think he's going to concentrate on is developing the lunar lander for NASA. And that's absolutely vital, I think, for the sort of profits he needs to make to keep his Blue Origin scheme going, and also for his reputation, because Musk has now got a reputation. If you ignore the Starlink satellites, he's basically pioneered private space exploration and exploitation in terms of the public eye. So he's actually liquidating about $1 billion per annum of Amazon stock to fund Blue Origin. Now, there are very few people in the world can actually do that. He's one of them. So in terms of what he's doing, he's modified the design of the lander, the one that he's offering to NASA as an option for them to choose. So not only will it fit inside his own New Glenn big rocket, but it will also fit inside the SpaceX Vulcan Heavy, or the Vulcan launcher being developed by the United Launch Alliance. So that's a good plus point. It means that it's capable of being launched by a number of different rockets. He was having problems with his BE-4 engine. We think those are now either overcome or well on the way to being overcome. And he's basically now concentrating on getting a serious competition going with Elon Musk and SpaceX. So that's really what drives things forward, competition.
And commercially, that it's the only way that space is going to become truly viable. I mean, SpaceX, as you said, they've pioneered the whole reusability side. Again, I was sat in meetings years ago when people were laughing at them and saying, "Oh, who are SpaceX? They know nothing." Nobody's laughing anymore. And the reusability aspect with Falcon 9, Falcon Heavy, etc. They proven technology. Slightly more interesting with Starship, but again, you only had to look at the early days of NASA with the Mercury program and Kaputnik and all the other explosions that were happening in those days. Some of the initial launches, barely getting off the launch pad, some of the others just blowing up on the launch pad, some of them blowing up when they got off the launch pad. A bunch of Mercury 7 astronauts watching it and going, "You really want me to sit on the top of that thing?" So it's... And people say, "Oh, we're 60 years on from that." Space is still hard. Space hasn't got that much easier. Yes, we've got vastly more computational power now. We can do fantastic fluid dynamics analysis. We can do all sorts of wonderful things with the computers that we weren't able to do back in the 1960s, but it's still damned hard.
Yeah, well, just sort of to recap on that, the last two of the SM9 serial number 8 and 9, basically, of his rockets, got up into space, or the edge of space anyway, about 10 kilometers up. They did their belly flop. They came back down to the launching pad, but unfortunately, they didn't make a successful landing. Basically, they were coming down too fast and at a bad angle. This last one, SN9, one of the three rockets that was supposed to slow it down failed to ignite, so it came down too fast and at an angle, and when it hit the ground, it basically exploded. They have the SN10, the next one, which was incidentally sitting on the launch pad right beside this big explosion, but as far as we know, it wasn't damaged. It's ready to go. It has been fitted with new Raptor engines. We've heard that they have announced road closures in the area at the base in Texas, so it looks as if they're liable to go reasonably soon. We haven't got an actual date on that yet, but there's one thing about Elon Musk: he doesn't let minor accidents like rocket explosions put him off. He just keeps plugging away. So I think we can expect to see something happening with SN10 within the next couple of days, probably weather permitting. And if they've sorted out the problems with the engines, hopefully he'll get that one down to a safe landing for reuse again. And that's the critical thing.
That's the thing, the launch cadence, the kind of launch frequency. SpaceX are outperforming pretty much every other agency on the planet anyway, in terms of sheer numbers of launches per year. You got Rocket Labs down in New Zealand doing a fantastic job. They now seem to be developing a really reliable launch system. Roscosmos have been doing it for decades, but nobody's launching with the same kind of frequency and cadence that they are. I mean, they were literally launching two Falcon 9s within hours of each other was the plan, and this is part of Musk's kind of dream to set up as he was moaning at the Federal Aviation Authority, the FAA, saying, if we're going to become a spacefaring, society, as it were, you've got to change your edict, as it were, to let me launch quicker. But then the issue against that the astronomers and pretty much everyone now, defense industry, etc., are all starting to get very, very twitchy about, is the sheer number of launches and the sheer number of things that he's thrown up. 143 satellites on one launch quite recently in one go. 143 satellites is 5% of the total active satellites in orbit. So this is becoming, it's a real, I've always had a love-hate relationship with these guys since day one, and all power to SN10. Hopefully that's going to prove a successful landing. You only have to watch some of the YouTube live streams of these. There's a guy called the Everyday Astronaut who his excitement is fantastic to watch, and it really does enhance what you're watching. And these are only like relatively low altitude tests. The last one was up to 10-12 kilometers. They're not going into space, but these are still more watched than most real launches are. Some of the big space agencies don't get as many viewers watching a real launch of a real rocket into real space that they're doing with test launches up to a few kilometers. So all power to them on that one. And I hope that enthusiasm spills into what the UK is trying to do, which takes us on to our next story. Quite nicely, with what's happening with the UK space and UK Space Agency. Big news this week. So one of the most right-wing, conservative, Tory fangirl newspapers, the Daily Telegraph, they broke a big story earlier this week about the transfer of power from the UK Space Agency. Now, there's two sides to this story. One side is that the UK Space Agency have been going now for quite a number of years, building up capability for quite some time. There's some really, really good people who work at the UK Space Agency. I know many of them are very smart people. They were asked to perform all sorts of studies and develop the whole UK space program in terms of strategy, etc. And they were interfacing with lots and lots of the organisations involved in the whole supply chain. Then the whole OneWeb thing happened last year, and Whitehall on the one side are denying that this has got anything to do with the recent decision, and then the newspapers, various newspapers, not just the Telegraph, but the Independent, which is a very independent newspaper, and various other news agencies are getting behind this whole, they think that the UK Space Agency almost had a slap on the wrist. I don't believe some of what the hype behind some of these stories. I think some of them have been exaggerated, but there's definitely been this transfer of power. Now, there's been a desire to kind of move this over to the business sector. So what's happened is the UK Space Agency's key strategy and decision making has been moved over into central government, into what's called BASE, under the business secretary in the UK. And there was all sorts of speculation as to whether or not this was due to what happened with OneWeb. OneWeb was a big acquisition. So OneWeb were a defunct, bankrupt satellite company based out of the US. And again, we're looking at large constellations. The UK, post-Brexit, were kind of taken out of the whole Galileo program, which is the big European-wide program to develop a system comparable, if not better, than GPS. So for position, navigation, and timing, which so many elements of our society are so reliant on. Most of the shipping, navigation, etc., things that we rely on day to day for our economy, for our food, for all sorts of things, is heavily reliant on what's called GNSS and PNT, position, navigation, and timing. So all of this was kind of tied into this acquisition of OneWeb. Now, a lot of the engineering and space science community, my team and various other teams that I work with, all looked at this and went, this is wrong. This is really, what you're trying to do with this is not what it's geared up for. OneWeb was never geared up for this. So the space agency themselves did a whole slew of different critical studies. They were talking to lots in the engineering community, major space primes, and they all came back with the same conclusion, that this really wasn't the right acquisition. And it was 400 million quid, 400 million pounds. It's now been further augmented by Japanese SoftBank and various other organizations up to about 1.4 billion. So this is not a small acquisition that's taken place of the OneWeb system, but still there was these lots of people in the space science and the engineering community saying it's wrong. It's just fundamentally wrong. So what's happened in the last few weeks is that, yes, there was going to be this orderly transfer of some of the responsibilities from the UK Space Agency over to the business secretary and the business secretary, the BASE team, etc. But the coincidence with the stepping down, and it is at the end of his tenure, so it is a coincidence, but the CEO of the UK Space Agency stepped down quite recently, and we know of several other people who have moved out of the UK Space Agency, gone into MOD and various other organisations. So it doesn't look good, is the thing. The PR and the handling of this has been really, really bad in terms of the UK space aspirations. And the UK does phenomenal things in space, in terms of the overall supply chain, the ability to, from inception, from the great minds that we've got who think up some of these missions, to the teams that worked on instrumentation. And that goes all the way up to the biggest projects in the world, like the James Webb Space Telescope. The instrumentation, the key instrument from that, the MIRI, is at University of Edinburgh and the ATC Centre up there. And there's fantastic work in instrumentation that goes back decades for the UK from all sorts of different space missions. And the UK, 50 plus years ago, we had a nascent space program. We launched a rocket from Australia, from the Woomera test site. And then the focus really went back into satellites, and that's where it really should belong still in many respects. You've got SSTL, sorry, satellites, who develop 40% of the world's small satellite satellites that launched. You've got Clyde Space up in Scotland. You've got a whole range of different companies in the UK, and you've got marvelous space hub clusters like the Harwell Space Cluster in Oxfordshire, which is currently doing incredible work in terms of COVID vaccines as well. But they've got the Diamond Light Accelerator. They've got over 100 different space companies based there doing phenomenal work. And then you've got what's happening down in Cornwall and the build-up of the space infrastructure down there for Virgin Orbit. And then you've got all the companies up in Scotland, and we'll go on to that in a second. But this whole thing that's happened doesn't look good. And, there will be people watching this who will be nodding their heads and go, yeah, you're right. It doesn't look good. No matter how you spin this, it doesn't look good. So I'm hoping over the coming months, the government are going to be more honest and more transparent about what's really happening here. And they're saying that the UK Space Agency is still a huge part of the UK space infrastructure, and it will be, and it is. But the negative press that this has garnered, and is still garnering, there was an article again in the Telegraph today kind of admonishing what was happening here. So I'm hoping that this is going to evolve and kind of show that the UK can do great stuff, because it's the last chink in the chain, as it were, is launch. We can conceive these rockets, we can conceive these satellites, we can design them, we can engineer them, we can test them. There's a new test facility being built at Harwell. We've got all of the kind of key bits in the jigsaw, apart from the very last one, which is launch. And now with Virgin Orbit successfully launching from Mojave, hopefully Newquay is going to be doing that with Spaceport Cornwall in the very near future. And then we move on to the second part of this story. So the other big news this week is the news that Lockheed Martin, who are one of the world's largest defense companies. So they're responsible for huge defense projects in the United States, from the F-35, which is the most advanced stealth fighter in the world that lands on the aircraft carriers that my company worked on, the Queen Elizabeth aircraft carrier. Fantastic aircraft. And they have a decades-long heritage in space and rocket science. They've been working on every program for so many years now. Recently they did the OSIRIS-REx mission. They're working on the Orion module, which is now pretty much complete and ready to go for the Artemis launches, which is going to mate up with the European service module. So this is a company who really do know what they're doing. As Terry was saying about the United Launch Alliance earlier, they're part of the ULA. They basically do a lot of the competitor launches to SpaceX, although the cost issues obviously are now becoming a bit of an issue for even companies that size. So Lockheed have had a vested interest in this for quite some time. The UK Space Agency invested a lot of money into pushing Lockheed for the launch sites in Scotland, for these vertical launch sites. And initially, they were going to be tied in with a launch site at Sutherland on the Moyne Peninsula. Now, Sutherland always had a few issues, shall we say. It's a site of special scientific interest, the SSSI, and there's a ton of objections to this being used as a launch site, being raised by the Royal Society for Protection of Birds, by Greenpeace, by the Wildlife Trusts up in Scotland, etc., because it's a really pristine site. And I know that the team involved in Sutherland have done fantastic work on the environmental studies, etc., but there's still these objections. And there's a guy called Anders Paulsen who owns a vast amount of land nearby, who's still suing them to try and get this launch site overturned, because he doesn't want it to happen. It's gone through kind of Scottish government ascension there, and they've said, yeah, this is all okay, even though there were hundreds of objections to it. And a lot of that could have been tied into Extinction Rebellion and various other pressure groups, but there are still issues. So you look at the different potential sites, and the one that's been moved to by Lockheed Martin is up in Shetland. Now, Shetland and the Western Isles, which are these two sites up in off the Scottish coast, are both very good, both from a launch range trajectory perspective. They're safer launch ranges, for example. Weather issues, there's obviously you've got notable weather issues up in the north of Scotland, but for these polar sun-synchronous launches of small satellites, they're both good sites. The Shetland site is an ex-military site already, so you're effectively going on brownfield, so there's no major issues with that. Now, what Lockheed have now come out in the last few days and said is that, right, yeah, we're going with Shetland. That was announced a few months ago. What they've now said is that they're going to be partnering with a company called ABL. So ABL are an unknown entity, as it were. They have yet to successfully launch anything. They're building this RS-1 rocket, which is a kind of relatively smallish rocket compared to, say, the Vulcan Heavy, etc. I think it's about 88 feet high, capable of deploying large numbers of small CubeSats into orbit, and I think that's going to be a good thing. The other thing with this RS-1, this ABL rocket, is it's almost like they're calling it a rocket in a box. So all the launch infrastructure basically will fit inside shipping containers. Now, for Shetland, that's perfect, because then you can just ship the shipping containers and essentially the whole package over to the launch site in Shetland and just let it go. So it's going to be kind of almost like what's happening in New Zealand with Rocket Labs, similar kind of scale, but almost more portable. And it's quite interesting. It's very similar to the approach being taken by Virgin with what they're doing in Yuki, where they're going to have what's called a TGOS system, which is essentially a big launch infrastructure platform with all fueling systems, test systems on the back of a truck, in essence, and a small launch control capability there, and range safety officers, etc. The key blockers still are to UK getting there, as it were, and UK really want to get there first. That's their goal. They want to be the prime launch site for Europe, and one of the key blockers is government. So this transfer of power from the UK Space Agency over to BEIS may help with that. We don't know yet. All of the what they call statutory instruments, the SIs, have still got to go through Parliament and gain royal ascension, and they've got to get parliamentary ascension, etc., to effectively say, yes, all of these regulations are fine. And there's so many different regulatory agencies involved here. You've got the Maritime Agency, you've got the Wildlife Agencies, you've got the Nuclear Fuels Agency, you've got the Defence Industry, you've got all sorts of different people who have got to effectively all come together to make this happen. And then you've got the insurance implications. So the insurance on a small CubeSat could be enormous. It could be double the cost of the CubeSat. So therefore making it almost impossible to launch. And when you've got the Indians doing such phenomenal jobs at ISRO, PSLV launches there over in India, you've got other countries like Iceland, Skyrora, big company up in Scotland who are developing rockets. They did one of their test launches from Iceland because they couldn't launch from the UK. And then you've got launch sites in Sweden. Everybody's kind of vying to be the first to go into space, as it were, from Europe. And it's a big thing. And I think Lockheed moving up to Shetland they're not stupid. They know what they're doing. So them moving up to Shetland was probably a smart move on their part. They saying that no, they're not the launch provider. They're not going to run the site. SSC, Shetland Space Centre, are going to run the site. They're going to kind of be the arbiter, as it were, the mediator. But with their contacts and who they can bring in, it's really interesting. The big elephant in the room, sorry for my long going on about this, the big elephant in the room is that Scotland right now have got a very, very good leader in Nicola Sturgeon, the First Minister. And all through the COVID crisis, she has demonstrated really good leadership over the Scottish people. And she's been extremely succinct and very good about demonstrating that she's following the science, etc. And she has massive approval ratings. So anyone listening in the US will know about approval ratings with ministers. So, for example, the approval rating of the UK Prime Minister is at -54. It's most people think he's not particularly great. That's up to them. That's not going into the politics. The Scottish First Minister has got a very good approval rating, so it's in the very high plus numbers. So she's very popular, and whether or not that's justified, I'm not the one to decide, but those are the facts. She has got very high approval ratings. She's also pushing to have Scotland devolve, so Scotland split from the United Kingdom. Now, the issue you've got there is that the technology safeguard agreements, which the UK launch providers like Lockheed Martin and Virgin, who are US companies, and ABL, who are a US company, rely on these TSAs, because they effectively, there's a thing called ITAR, which is the International Trade and Arms Regulation, which basically governs all sorts of things between the United States and what technologies can leave and etc. in the United States. Those TSAs are signed with the UK government. So Scotland devolves. Going to be interesting. Let's put it that way. So that's the elephant in the room. Terry, I don't know if you've got any thoughts on this. I think he's frozen. He's frozen in a kind of, he's got his eyes shut. I don't think he's gone to sleep. But I think he's frozen in an eyes shut kind of way. I'm going to check from my producer on the chat form just to make sure we're okay. Are we all still good? Yeah, I think we are. Just carry on. I'll just carry on talking. it's very, very interesting what's happening here in respect to UK launch, and I can't see much changing in the next few months. I just really hope that what's happened, as I said, with the business secretary and what's happening. The UK is obviously hosting one of the big climate environmental conferences later this year up in Scotland. It's called COP26. That's going to be held in Glasgow towards the end of the year. So the environmental side is also a huge side for UK launch. And what we're hoping for is that the UK is really going to drive home, sustainability, clean launch capability, well regulated launch capability, etc. We shall see if this happens. I'm just going to keep talking until Terry comes back. But that's the big story, I think, from this week. This and the Mars landers. We were going to talk about magnetars in a minute. That was Terry's big story, so I'm not going to eat in on that. If anyone's got any questions in the audience, please fire your questions in, because we're more than happy to answer them. If anyone's got any questions, I know we've got quite a few people listening tonight. Our last show, which was fantastic. We had over 110, 111 people watching the live stream. We've had over 350 watching us on average over the past year, which is amazing. We're now streaming on Spotify and various other things as well. So it's a lot of fun. It's been described as two best mates chatting down the pub. He's back. Hello, Terry.
All right. Yes. I don't know what happened there.
It's okay. Right. Yeah, I've just been saying it's like two best mates chatting down the pub most of the time. I've just been finishing off on the whole, what's happening up in Scotland. I don't know if you got any thoughts, Terry. I mean, Northern Ireland's a big player in this. You've got Thales Alenia, a massive company, and Bombardier, all based out of Northern Ireland. Northern Ireland and the island of Ireland would make a phenomenal launch site, in my opinion. I mean, there's so much potential up there, but I don't know if you got any thoughts, Terry.
Well, I was just going to say, you might think that Unst, as the most northerly of the Shetland Islands, was perhaps the hardest to get to and the least practical. But actually, it has many advantages. It has a very good harbour because it used to be a really major fishing port. And unlike Sutherland, which the site there doesn't have a harbour, and although it's on the mainland, it's actually many, many tens, maybe scores of miles away from the other nearest good access point. So if you're shipping a rocket up there to launch, it's not that easy. And in fact, as we were saying earlier, there's a bridge there that simply won't take the traffic. So it needs a lot of infrastructure development, and also has the advantage of being that much further north. It's ideal for polar orbiting satellites. So that's really all I wanted to add. I don't know what you said there when it was cut off.
No, it's interesting as well. There was a really good documentary on the BBC Parliament channel, which is something I never watch. But I was flicking through my TV about a week ago and just stumbled across this programme, and it was in Gaelic. It was on one of the obscure BBC channels, and they were talking about Sutherland and looking at the pros and cons. And as I said, there's some real pros to it. I mean, the regeneration for the local community, the fact that a lot of people in that area are afraid that people just leave. There isn't this kind of sense of community and the local jobs, etc. So I can see where each of the launch sites is coming from. The remote ones, Prestwick, obviously it's a major international airport already, but of all the other launch sites, they've all got a lot of heart. They've all got a lot of passion. They all want to make this succeed. I just don't see, and there's a lot of people who agree with me on this, some serious senior figures who agree with me on this. I just can't see that many launch providers in such a small space is going to work from an economic standpoint, from an infrastructure standpoint, from a need standpoint. So it'll be, I don't know if it'll be survival of the fittest. It'll be, let's see what happens. Because the United States, you've got Wallops, you've got Vandenberg, you've got the Alaska site, you've got obviously the Cape, you've got Edwards. You've got basically about the same number of launch sites in the continental United States as they're trying to squash into Scotland. So, interesting times ahead, shall we say. We've covered that one in huge amounts of detail. We covered the Mars one in huge amounts of detail. Terry's got a great story now on magnetars.
Right, the misbehaving magnetar. That's the nice title. The boring title is that it's called Swift J1818.0 minus 16.07. So we'll just call it the magnetar. And what is a magnetar? It is an incredibly dense, highly magnetized collapsed star, basically. It's a neutron star. And this is the first thing where we start to sort of give you things that will blow your mind. A neutron star happens whenever a big star, not big enough to go supernova or fails to go supernova for whatever reason at the end of its life, and it collapses to an incredibly dense star. And these are figures that you really cannot comprehend. If you had, say, a liter milk bottle made instead of milk, let's say it was made of uranium or platinum, some of the densest elements we have on Earth, you would notice it was heavy, but you could pick it up, okay? With a neutron star, if you had 1 teaspoonful of that material, it would weigh 4 billion tons, not 4 million, 4 billion. Incomprehensible. It's matter basically as dense as you can compress it, leaving aside black holes, which we'll leave for another day. And partly because it has become so condensed as it collapses, it also concentrates what was already quite a strong magnetic field. And these things have the strongest magnetic fields in the known universe. And again, this is a figure that's hard to comprehend. It's 1,000 trillion times stronger than the Earth's magnetic field, which gives us the aurora and makes your compass needles point north and so on. 1,000 trillion times stronger. By far, by many, many orders of magnitude, the most powerful magnetic field that we know of. So this thing is incredibly magnetic, and it's spinning rapidly, and it is sending out pulses of radio waves, lots of other things as well, but we're detecting them by the radiation in the radio wavelength. This thing is about 15,000 light years away, just to give you some idea of that sort of scale. It's not the direction, but it's about halfway from where our sun orbits to the center of our galaxy. We're about 30,000 light years out from the center. This thing is about 15,000 light years away from us. And the fascinating thing about this is that it has been misbehaving. Pulsars are normally extremely regular. In fact, you can use them almost as highly accurate clocks because they're spinning so regularly, and the beam of radio waves that come from them sweep past us like a lighthouse beam incredibly regularly. There are little glitches that happen now and again, which is another matter, but in between the glitches, the frequency of the signal that we get from a pulsar is incredibly accurate. This thing has started to misbehave. Back in May of last year, it was giving off pulses that were like a pulsar. And a pulsar is basically a spinning neutron star, not with such a strong magnetic field, nevertheless it has some. And this beam of radio radiation sweeps across the Earth incredibly regularly. Then in June, the signal started varying, and it became sort of basically highly irregular, difficult to describe because basically we never discovered anything like this before. Now, from May to June, 1 month, that's incredibly quickly in terms of astronomical timescales. So what was happening? We simply didn't know. Then in July, the signal changed again, and it became basically a mixture of what you would call signals from a pulsar, the pulsing radio waves, excuse me, and the sort of normal signals that you get from rotating magnetar. And we simply don't know. That's why this thing is so absolutely fascinating. The latest theory is that the magnetic axis is not aligned with the spin axis, which is a bit like what we have here on Earth. The north and south magnetic poles do not coincide with the Earth's north and south geographic poles, which determines how it spins on its axis. And in fact, our magnetic poles are shifting all the time, which is another interesting thing. But that's a lot easier to happen on the Earth, where we have a liquid or semi-liquid core and a semi-plastic mantle around it. The material in a neutron star is pretty much the same from the surface right down to the center, and it is so dense that you cannot really imagine anything inside it shifting around. But nevertheless, for some reason, the magnetic axis on this object is misaligned, as far as we can tell, with the spin axis. Even if that wasn't the case, just contemplating something as weird as that is just absolutely mind-blowing. And this is what fascinates me about astronomy. What do you think, Nick?
It's one of those things. When I worked on a project called the SKA some years ago now, about 10 years ago, the Square Kilometre Array Telescope, and it's one of the key areas they were looking at is that of magnetic fields in space and being able to use them to map certain regions of space. So anything with these super collapsed entities, between white dwarfs through to neutron stars through to black holes, you are bending the laws of physics pretty much to breaking point. And that, to me, is what's so fascinating about them. The fact that we still don't know. We're still discovering new things all the time. We've had the recent excitement with the Venus phosphine story that now turns out it may not have been. And it's the beauty of science. And we've said this so many times on this show, in that, we try and do the "and finally" story sometimes, which is, typically the one where we just don't know, we don't know what's going on. And we can talk about what we're doing on Earth in terms of launches and in terms of rocketry and our own solar system. Once we get beyond the bounds of our solar system, it's literally all bets are off. Betelgeuse, classic example. For decades, centuries even, we thought, oh, it's this distance away from the Earth. Now it's not. Now it's closer. And that's with having the Hubble Space Telescope, the Kepler telescope, etc. We've had some incredible instruments in orbit and on Earth able to do these precision measurements that we thought were going to stand the test of time, and we're still getting it wrong. So, we're currently imaging a supermassive black hole in the center of our own galaxy and stars kind of orbiting it. We can't see anything in the middle because it's a black hole, but we're seeing these things. You had the whole first images, ALMA and various other radio telescope images of a black hole that up until a few years ago, nobody knew what a black hole looked like. I remember talking to some of the CG team who worked on the movie Interstellar. These are Oscar-winning computer graphics artists. And when they were given, Kip Thorne was the advisor on that movie, and when they were given the data, they said, okay, they took the data away, and they came back with this visualization of a black hole. And the scientists were saying, that's not what a black hole looks like. And then lo and behold, it's exactly what a black hole looked like, because the data that the visualization team were given, that's what the models predicted. That's what the models came out with. So for years and years, everyone thought a black hole looked like the classic 1979 Disney movie, The Black Hole, and it's this swirling cloud and everything being sucked in. Turns out it doesn't look like that at all. And they've proven it now with direct imaging. Who knows what's going to be coming up? We've got exoplanet discoveries potentially, coming out of our ears right now. And then the follow on with the James Webb Space Telescope, which we're going to talk about in huge depth, hopefully towards the back end of this year when it launches and starts to head out to its Lagrange point. It's one of those great things, and this is what I love about these kind of, they're almost like fireside chats. And one day Terry and I are literally going to be by a fire. We're going to get a fire pit going in Harwell next to the space store, and we're literally going to sit around the fire and just chew the cud on this. It's the best part of doing this show.
It really is.
Yeah, we go through the stories each week, and I'll have a rant about XYZ or whatever, and then Terry will come out with some mind-blowing science story that I'm looking at it going, huh? It's fantastic. It really is. So I know we've had a few minor technical niggles tonight. We're using quite a new system called Restream Studio. We've gone away from using some of the old technology. Terry's just got himself a new headset because the sound muting capabilities that we had in other systems like Zoom, etc., we don't have in this. So we're still kind of powering through every week in lockdown, and we're doing it from the goodness of our hearts, from our own homes, or in Terry and my case, I think an office. Terry's surrounded by books, I'm surrounded by keyboards and meteorites and all sorts. And we've got this great team in the background, Luke and Latch at Space Store, who are literally, delivering this amazing resource, hopefully, to all of you each week. And the numbers speak for themselves. We're so pleased. There's so many people of you watching and listening. So, and we're just loving it. It's what I love to think of as the best STEM. This is what science, technology, engineering, and maths is all about. It's about, engaging with people. It's about encouraging the next generation, etc. And that, going back to the opening story with what happened with the UAE today, is what I love most about it. The fact that they really focused on what they were doing with STEM and what they were doing with encouraging, the next generation, and having such a high proportion of female scientists on the project as well. Having two daughters myself, it's amazing to watch things like that and to see the encouragement that hopefully that'll bring to the next generation of science. So I hope you've enjoyed tonight's show with all our little technical niggles and my rants and Terry's great science. And any final comments, Terry?
Just to go back to our friend Beetlejuice, and with Valentine's Day coming up, there's a nice angle on that. As you were saying, it turns out that it's a bit closer to us than we thought. It's therefore a little bit smaller and so on. And we now know that it's very unlikely to go supernova tomorrow. They're estimating now about 100,000 years, because what happened basically at the end of last year and earlier this year, it was dimming much more than ever done before. So everybody suddenly started getting interested in it. And they've now done a lot more analysis. But go back to the Valentine's Day angle. It's a giant red pulsing heart, if you like, out there in the universe. Still, although it's smaller than we think, it's up to about 19 times the mass of the sun. It's pulsating because it's a variable star, and it's red, the color of love. So you can imagine it as a giant red pulsing heart. And you can take your beloved out on Valentine's night, if you can't do anything else because of the lockdown, and point to Beetlejuice, which you can see easily with your naked eye, and there's the Valentine star.
What a
to finish.
It's I mean, that's the thing. We normally kind of finish with a what's on and look up, etc. Orion is a beautiful thing that anyone can spot. And there's a big push this year, especially with Valentine's Day coming, to not buy loads of plastic tat and, wasting resources, wasting the planet's resources for things that will either end up in the bin or won't be used. And everyone likes to do something really special for those around them. So I can't think of anything nicer, actually, if the clouds abate ever in the UK, but wherever you're watching, hopefully the clouds will, to go out, wrap up warm, get a nice flask of something hot. It could be whatever you prefer to drink. If it's snowing, all the better, because it'll be really beautiful. And just share that experience with somebody. It's absolutely fantastic to go out and, with the comet earlier this year, it was wonderful sharing that with, the people you love. It's really, really fantastic to share something that they've never seen before, or they may not have ever seen before, and to be able to do something like that, I think is really, really special. So that is a great call, Terry. I think great one.
Okay,
love it.
One other thing, again, you're not allowed to hug at the moment, but you can see the old moon in the new moon's arms, which is whenever you see, as the new moon appears out from being between the Earth and the sun, and it's a thin crescent, whenever the sky gets dark enough, you can actually see what's called the Earth shine, which is sunlight that has shone onto the Earth, been reflected off the Earth onto the moon to illuminate the dark side of the moon, the side that's not getting direct sunlight, and then reflected back to Earth to our eyes for us to see it. And you can see the Earth shine, the shine from the Earth, the light reflected off the Earth onto the moon inside the crescent. And the conventional and the beautiful name for that is the old moon in the new moon's arms. So the new moon is giving the old moon a hug. And lucky new moon, because nobody else can hug at the moment.
So on that lovely note, hopefully you'll have a really restful few weeks, anyone who's listening. If you're working at home, we've all been working at home for quite some time now, stick with it. Fantastic work again, thanks to science, the amazing scientists, people like Oxford, AstraZeneca, etc. Hopefully you'll get us out of this horrible mess that we're in the not too distant future. I know members of my family have had vaccines already, and it is happening. So one day we will bring this to you with Terry and I in the same room itself, somewhere either in the UK, or I'd love to go back to Northern Ireland. I absolutely love it over there. Beautiful, beautiful country. And I'll hand you back to our amazing friends at the Space Store, who have been great support, as I said, since day one. Give them your support as well. The small businesses are key to the future of our economy, so definitely give them as much support as you can. Over to you, Latch.
Brilliant. Thank you so much, Nick and Terry. It's been another amazing roundup. Great listening to you guys every other Tuesday. I always learn something new. Once again, I do apologize to our audience for the brief technical hitches we had today. I know we had some amazing pictures and slides to share, but you guys weren't able to see those. So hopefully we'll get that fixed for next time. Next up on Space to Live, we do have David Whitehouse, and we'll be talking about his latest book, Space 2069. So tune in on Thursday at 7 p.m. for that. And thank you for tuning in today. It's been another great show, Nick and Terry. You guys have been such patrons of Space Door. It's amazing to have you on, and we'll see you again in a couple of weeks' time for another Space Roundup.
Cheers.
Cheers. Bye-bye. Stay safe, everybody.
Adios, amigos.
See you guys later.
Bye.